Hello, folks. Welcome to Rational Science, the only site on the internet that does physics at all. Everybody else does mathemagics. What is mathemagics? It's the movement of concepts. That's what everybody does. Why? Because they never define what an object is, essentially. Anyways, it's pretty cold here in Germany, and I think it's about 2 or 3 degrees. The other day was like 5 below 0. So yeah, I'm well dressed, overdressed maybe. And someone asked there, maybe I should just turn the heater on or whatever. I stopped using a heater 2 or 3 years ago. Partly because of waste of money, but partly because of health. It's an issue that I think I don't need it. I'd rather cover up, and it also gives me an incentive to you do some gym. Otherwise, just stay here and just freeze to death. Anyways, we got a great day today. I'm going to skip the extinction segment today because we got quite a bit of material today. Lots of questions, especially from mathematicians or mathematically inclined or people who think they know something about physics and think that math has something to do with physics. And yeah, we have a name for them. And so let's start there. And then, by the way, later on I'll continue with the main course today, which is, the time travel. Can we time travel? Okay, so let's begin with our segment here with the questions and comments that people made since last time. And the way I'm going to begin today, I'm going to start by defining an important word that we're going to need today. And it's this word idiot, idiot. Idiot, idiot, you can pronounce it any way you want. It's an individual big ideas. We call them idiots or idiots, right? Comes from the ancient Klingon, meaning big idea. You have little ideas, just ideas. Then you have idiots, right? Big ideas. And some of these people, just about all of them, think that math has something to do with physics, okay? And I think we're going to set them straight today, okay? Yeah, no, math has nothing at all to do with physics. In physics, we do not use math, okay, at all. Numbers, equations, we don't use any of that, okay? Not in physics, okay? Now, maybe they use it somewhere else, certainly not in physics, and that's what we're going to show today. So we have our first candidate here, visitor. He says, math is not the language of science, but yes, it is the language of physics. Okay. Where have you been for the past few hundred years? You can make physics what it isn't. You can't make physics what it isn't. What you're looking for is natural philosophy. In the 17th century, they used to call this so-called science. They called it natural philosophy. What did that mean? Well, it meant that, they were trying to figure out how this universe works. That gradually evolved into experiments and equations, measurement and equations. And the question is whether experiments, measurements, and equations have anything at all to do with physics. Okay, that's the question. And so the first thing we need to realize here is that this fellow did not define physics, so we don't know what he's talking about. Until he defines physics, we won't know that what he says there is true, or that it's rational, or that it's consistent with what everybody understands for physics. Okay, and by everybody, I mean everybody except the mathematicians out there. Okay, so he forgot to define physics. Aristotle defined physics. He's the guy who invented this word. That's where we got the word from. And he didn't define it as it's defined today. So that's the first thing you should know. The fact that the mathematicians changed the definition in the last 400 years doesn't mean that we can't change it again. Okay, we can change definitions. What if we find that they are irrational? Okay, the ones that these people are using. Okay? In science, we don't care what the mathematicians call physics or whether they all agree. If it's irrational, science rejects their claim. So yeah, you can't use authority here and say, oh, all the mathematicians on Earth voted for the definition of physics. That's what they do. That's what they call physics. We don't care. Science doesn't care. Okay. Science, physics is whatever rational definition of the word physics says it is. Okay, and you don't have to like the definitions. All you have to do is propose one that is more rational. Like a better mousetrap. Otherwise, you have to keep your trap shut because you have nothing to offer science. Okay, and this guy says also 99% of humanity doesn't know what the difference between description and explanation. I don't think he knows either, but, how do you explain with math? He's insisting on math. How do you explain with math? So if physics is about explaining, and this guy says that we use math in physics, then the question is, how do you explain with math? That's all he's got to do, explain that. Okay, another fellow says, science and physics is about understanding nature and universe. Understanding, here means explanation of causes and mechanisms. That's what an explanation is, not mathematical descriptions. So he continues, he says, in science, engineering, and physics, we use mathematical representations to help describe and explain. Absolutely not. Okay, math has no power to explain anything. Okay, math can only describe quantitatively. And in science, the question then is physics about explaining or is physics about describing? Okay, and one of the problems there that we have, some people have out there, what do you call them? Idiots. Okay, and what do they say? They say that an explanation, it's just a bunch of descriptions, a listing of descriptions. We're going to debunk that today. And by debunk, I don't mean we're going to convince you and persuade you to believe. That's not what we're here for. Belief belongs in religion. Debunking here is in a different context. Debunking means we define terms, and then using those definitions, we use them consistently, and we show that logically something fails, a theory or whatever. Okay. Now you don't have to agree to those definitions, but again, that means you have to propose a better mousetrap or keep your trap shut. Okay, because you don't have anything to contribute to science. Okay, here we have mathematics. Yeah, is correct, probably. It's just a description of the universe, just as the menu is not the dinner. You cannot eat the menu. Okay, mathematics is not reality, just a description of reality. If mathematics and logic are the only things that enable you to describe the universe, what guarantees you that there is a deeper infrastructure than the mathematical description? Well, the first thing is, what does description have to do with physics? What does, unless you define physics, tell me what the definition of the word physics means, all that is worthless nonsense. You haven't said anything because you haven't defined physics. And then what is this nonsense about deeper infrastructure? What do they use these people are not even in the ballpark. They don't even know what questions that. They don't know what they're supposed to be investigating, researching, what they're supposed to come up with theories for. Okay? And so a rational individual seeks an explanation. That's, I guess, the deeper infrastructure that he's talking about, okay? The underlying causes, mechanisms of gravity, electromagnetism, atom, the workings of the atom, etc. That's what a rational individual wants to understand. Now, people who do math, they don't care about any of that, and that's why they don't understand even what the questions are. So when someone says, why does this pencil fall to the floor, Why does it fall to the ceiling? And they don't understand the question. Why are you asking that? It never occurred to them to ask that question. Why do things fall to the floor? And so this is where the problem is. This is where it starts and where it ends. Okay? Because these people are thinking in other terms. They have other garbage in their little tiny brains, ant brains. Okay, so here's another fellow says, math may be a language, but it's also a form of proof. Proof. What proof got to do with anything? Proof, it belongs to religion. Proof means they convinced you of something that now you have been recruited. That's what proof means. Okay, what is proof to you is a lie to the guy across the street. He has a different proof, that goes completely against what your proof is. Some people think it's space-time began with Big Bang, and other people believe that God made the whole universe. So there's different proofs out there for different people. We don't use proof in science. You should know that by now, unless you studied at the Cambridge Monastery or the the Harvard Cathedral. Maybe you studied divinity studies or something like that. I suppose you could say physics is more about data. What are these people thinking of? These people have no clue what they're even talking about, okay? Then it is about properties of a thing or action. Regardless of all of them require math to confirm or deny. I guess he's talking about opinion. What Popper said was, falsifiability? Maybe that's what he's got going through his tiny brain. I mean, all these mathematicians, they have no clue whatsoever what the issues are. They're not even on the same page. They're not even in the same planet or in the same universe. I mean, who knows where they are? And here's a last one says, seems to me normal human language is insufficient to describe phenomena with precision. We don't describe, and what does precision have anything to do with anything? We don't use precision in physics. This is as precise as it gets. You let go of the pencil, and it doesn't go below the, in this case, the table, but it doesn't go below the floor for some reason. It doesn't crash through the floor and go all the way to the center of the earth. That's as precise as it gets when, the pencil hits the floor. That's very precise, okay? If you need high precision, what else is there if not math? We don't need high precision. We don't need precision at all. Precision has nothing to do with physics. Okay, so let's get it right. Neither precision or accuracy have anything to do with physics, and you're not even in the ballpark. Says, if math is not the language of physics, then what is? English, German, Chinese? Well, you can use any language really to express physics, okay? Because as long as you stay qualitatively, you explain a mechanism, a cause, you're okay. We won't hurt you. This is how we do justice here. We use the dough roller or good old Excalibur there. We stab you with it, okay? So, you can use any language. Okay, but make sure it's qualitative instead of quantitative. Then we have there the definition. What is physics? Explanation of causes and mechanisms. Got it? We need an explanation of causes and mechanisms. We want to know why. What causes this pencil to fall always downwards, never to the ceiling? What causes the moon to be so faithful to the earth instead of flying out of the solar system? Same for the earth, flying out of the solar system, away from the sun. What keeps it? What prevents the electron bead from flying outside, the atom? That's what we want to understand, okay? And so we need a mechanism, a physical mechanism, not one using concepts. Again, concepts, like magic, okay? We don't use concepts. We don't move them around. You have to put a physical entity there, okay? Let's make sure we understand that. Therefore, the language of physics is illustration. Anyone who cannot make a movie of his mechanism, you know what a mechanism is? Like, how a car works? If you cannot make a movie of that, you're not a physicist, okay? So you should be able to make a movie of any mechanism you propose, because mechanism hopefully involve objects, not abstract concepts, okay? So we're talking about mechanisms, we're talking about causes, and we're saying that the language of physics is illustration, not math. What do we use math for? Math is only going to quantify something. It's going to give us a measurement, and you're going to put it in the equation and say, well, this is the description of its motion, so to speak. Yeah, that's like saying you can describe a chair. A chair has 4 legs, mathematically, right? 4 legs, 1 backrest, 1 seat, and maybe 2 armrests. Great, I described it mathematically. And is that physics? Is that science? Okay, so this is the issue. No, we have no use for accuracy or for descriptions in physics. We explain in physics. What do we explain? Causes and mechanism. So we have to go a little step backwards for these slow folks, slow pokes, slow folks. What? Because they never learned anything in college or in high school, wherever they went. You know, they went to these monasteries, I get these PhDs in what divinity studies or whatever, and they never learned what explanations are, what descriptions are, and what the differences are. So let's go into that. What is the difference between a description and an explanation? Okay, here we go with the first one. Okay, these are the proposed definitions in science. You don't have to agree to them. You just, if you don't, we don't agree, by the way, in science. We don't even agree to disagree. There's no such thing as agreement in science. That's religion again. In science, we don't agree. What we do is we define. And we defend our definitions. You don't like the definition, no problem. You propose a better mousetrap or keep your mousetrap shut. Okay, description, a listing of the properties of an object, image, or scene. You have a static image, static object, static image or scene, and you're going to describe it. What are you going to use? You're going to use primarily adjectives, okay? That's how you describe, because it's a static scene, nothing's moving. You should not be using verbs or adverbs. I can't imagine using that, but maybe there is some situation where it does. But in general, you're going to be using adjectives, okay? Because you're going to be describing images that are in front of the person's eyes. Now, what's objective is what comes out of the screen, okay? That's objective for all of us. Now, everybody interprets maybe something different from the screen. That's subjective, okay? But objective is what comes out of the screen. That's what we call objective, okay? Okay, and it doesn't mean that, you said, well, I saw it green. The other guy said, I saw it red. Well, that's subjective. Okay, narrative. We like that word, narrative or narration. Description of motion, okay, because there are descriptions where you don't have a fixed static screen. You have, so to speak, a film strip, a movie, right? And usually in a chronological way, right? So if you tell a little story or something that happened, well, just objectively, right, you go step by step and you say, this is what happened first, this is what happened second, this is what happened third, without giving your opinion, without giving your a theory. You just say, look, this is what I saw, objectively, okay? And that's called a narrative or a narration. Explanation, something totally different. Explanation, physical interpretation of causes and mechanisms underlying a phenomenon. That's what it is for physics. In philosophy, explanation, which is the other branch of science, by the way, interpretation of the reasons and purposes behind an action. Okay, why did someone do something? Okay, and we're going to see a couple of examples today. Explanation answers why questions, whereas description usually answers how questions. Okay, when they're narratives or narrations. Explanation answers why questions, and synonyms, physical interpretation, theory. Okay, so every time you say theory, you're not talking about description, mathematical or otherwise. You are talking about an explanation. Okay. Okay, so here we have a couple of examples. Maybe we can illustrate what I just said. Okay, so that we can, all zero in on the same notion that we're trying to convey here today. Here we have a car crash, okay, and so the cop says, what happened? The gal goes out, blah, 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 and says, and the red car struck the blue car. Well, that's not a description. It's already an explanation. It's already a theory. She's giving her opinion of how it happened. And not only an opinion, she's giving you an explanation, a theory, what she thinks happened, okay? And so, yeah, the cop just wants the facts, and she's not giving him the facts. She's already interpreting, okay? No, she should say, look, two cars crashed, or the blue and the red car crashed, or they bumped each other. That's a description, okay? You're just not giving any opinion, no theory. You're just saying they crashed, okay? The theory, that's for the lawyers for the insurance companies. The red car says, yeah, this guy, the blue car says the red car crashed into me. And the insurance guys on the red car say, no, the blue car backed up and hit me from the front. And then two others come in there and they have different theories. They say, look, there was a chain underneath the blue car and then pulled it backwards and hit the red car. And the other guy said, no, there was a chain tied to the red car to a truck and the truck moved forward and hit the blue car. And they have all these theories. Okay, those are theories. Those are explanations of what people think happened. Okay, that's the issue. But objectively, you have to say two cars crashed. That's a description. Explanation is when you say what she said, the blue car or the red car hit the blue car. Then you're giving a theory. Okay, let's look at another one here. Probably a little more closer to the land of physics. Really, it's from religion, but it's a physical interpretation. Okay, here it is. We have God. Okay, and here's our universal movie. What's a universal movie? Well, that's our tool that when we use where everything within a single frame is static. In other words, everything within a single frame, all we have there is location, objects, distance between the atoms in the universe. Everything in the universe is in a single frame there. Every object in the universe, okay? And we propose that matter is finite in the sense that it's countable. In other words, there's not an infinite number of atoms in the universe. Okay, there can't be. But that's the assumption that we start with here. Anyways, the point here is that God has nothing in that first frame on the left, and then on the second frame, the one in the middle, suddenly we have the earth, what they call the world, right? And we have Adam and Eve. So he created that maybe in 7 days. I showed only in 1 day, but he was creating one thing at a time, and that means that from zero, suddenly we went to something, okay? From nothing to something, okay? That's the religion version, at least from Christianity, okay? And here's the version from so-called science, mathematical physics, meaning, what do we call that? Religion. It's not even religion, it's irrational. So it's not even religion. Religion has an upper hand, a traditional religion like Christianity or Islam, etc. They have a little edge over mathematical physics because at least they deal with what seem to be objects. They talk about God and they're thinking about this magician, human-like magician. They say he looks like us or we look like him, right? And so we more or less get the idea, at least, that the objects are there. Now we have to explain how that magician made something from nothing. That's another issue. But in the case of general relativity, which is the one that talks about the creation of our universe, we got a problem because we got this situation here. We have nothing in the first frame, and suddenly we have this singularity, a little dot. I put it as a white dot into frame number 2, and eventually in frame gazillion over there, you have our universe today, right? What they paint as the W map thingy. Okay, so the question is, we're going to look at frame number 1, number 2. Those are the ones we're interested in, and the problem there is they always start at frame number 2. They say, look, the singularity, and suddenly it exploded, and blah, blah, blah. Okay, great. How did the singularity get there? How did we go from frame 1 where there's nothing to the singularity where there's something? Or was the singularity there for eternity, and suddenly, for whatever reason, it decided to explode? So, and the way they answer that is they say, well, it's an unscientific question because we have no way of proving the hypothesis, the theory, what came before the singularity or how it got there. Yeah, that's the only thing you had to explain. I mean, they have this nonsense where, they take the reel back. They say all the galaxies were closer together yesterday and even closer the day before. And so they take the tape all the way to square one and they say, really frame 2, and they say, okay, all this was crunched into a singularity. Yeah, we want to know how the singularity got there. I mean, if you can't answer that, your theory is bunk. It's garbage. I mean, that's the only question you got to answer. How the singularity got there. That's the only one we're interested in. The rest is nonsense. And to say it's unscientific is just skirting the question. Okay, so here's another issue here. Here we're going to show an explanation, I guess. Let's find out if it is. Okay, we have this. We have a motor, an engine, right? And car engine. And it talks about the oil, how it goes through there. And so it says, first sentence there says, motor oil is used to lubricate moving parts, clean, prevent corrosion, etc., right? Then that second one, oil galleries, are channels that carry oil to various engine parts. And then the next one says, the oil filter removes unwanted material from engine oil. Then the oil pan holds the engine oil. The oil pump keeps oil properly pressurized and flowing through the engine. So people say, see, Bill, you were wrong. Obviously, this is an explanation. It's a bunch of descriptions, right? Well, no, it ain't, okay? People confuse these things, and so we need to understand exactly what's going on here. This is a great example. Let's look at that first sentence again. Motor oil is used to lubricate moving parts, right? Okay, so the question is the following. What question does that serve as an answer to? Okay, what is the question? And the question is, I'll rephrase it, okay? Why did John lubricate or use motor oil to lubricate moving parts? And the answer is, yeah, the oil was put in there to lubricate the moving parts. You know, so we're answering not a question of physics. We're answering a question of philosophy. We're answering a question that involves not causes and mechanisms. We're answering a question that involves purposes and reasons. And then you have two on the bottom that I put. Philosophically, we can say this is what we're trying to answer. John oiled the parts so they would move. Okay, that's a question of philosophy. That's not a question of physics. It's why did John? What was the purpose, right? What was the reason that John did something? And in physics, you would phrase the maybe in this sense, because you're trying to figure out a why question involving causes and mechanism. You would say parts move because they are oiled. Okay, that's an issue of physics. The other one is an issue of philosophy. And when you say motor oil is used to lubricate moving parts, you're rephrasing a philosophical question, and people confuse this as a statement, a description involving, in this case, oil. Okay, it's not. Okay, it's a theory that is phrased in a way that it sounds like a description, and this is part of the problem. You got to keep in mind how it's phrased and what question you are trying to answer with the statement that you could consider a description. Okay, here's another case, and I showed this the other day. We have this fellow here, and his name is Casimir. Okay, Casimir is pulling on a donkey. That's what it seems like, right? But we're not going to talk about the theory here, so we can't use the word pulling. We can't use the word pulling because if you say pull, you're already giving a theory, okay? What we're looking at here, we're looking at description only, okay? Let's just talk about description. What can we describe? Well, we can say, and we're assuming this is just standing still. Well, we have a donkey on one side, and we have a rope tied around the donkey's neck, okay? And we see this fellow, okay? And what he's doing, we're going to call it a narrative or narration. What he's doing is moving his hands along what appears to be a rope or a cord or some elongated object. That's a description, okay? And now you say, well, Bill, it's obvious that, what you're illustrating there is that Casimir is pulling on the donkey. That's how the donkey went from A to B. That's how the donkey got closer to Casimir. Okay, well, not so. See, I have a different theory, okay, and I'm going to make something else visible here so that you can understand my theory, okay, and it's air, and I'm going to say, look, there's this wind behind the donkey. It's pushing the donkey towards, the Casimir. So there's a different theory for this phenomenon that you're staring at there. Someone might say, look, Casimir is pulling on the donkey, and another person might say, oh, no, it's the wind pushing the donkey from behind. In fact, you have all these people who talk about pushing gravity, and this is what they're thinking about. So again, when you use pull or push, you're giving already a theory. That's not what you're supposed to do when you describe, okay? So keep that in mind. Let me get rid of this one here. Okay, what if we had no rope? Okay, like we showed the other day. So we see this from afar. Maybe your eyesight is not good, so you can't see what Casimir is doing there. You're only seeing his hands move. You're seeing the donkey comes closer. We have no air or rope, or at least you can't see them. And so the question is, now everybody's baffled. Everybody says, how did the donkey come closer? I don't see anything there. And only because you can't see, you're assuming there's no physical object acting on a donkey. Okay, so this is the issue. The only issue here is that you can't see, subjective, right? You can't see or touch, maybe, whatever is in contact with the donkey, which is the same thing that we have when we let go of the pencil, right? You can't see or touch the whatever's pushing or pulling on this pencil. And so because of that, you say, oh, gravity, we cannot explain. We'll never be able to explain it, or someday we'll be able to explain it in the future. So you kick the can down the road. So you never explain it, because all you have to do is identify the invisible object that come in contact with a pencil, and then it's kid stuff. Then it's baby stuff for kindergartners. 10-year-old can understand it. Okay? But unless you put an object there, if you just keep doing math, equations and measurement, you're never going to figure out the cause, the mechanism that underlies gravity. And that's where we stand today. In 2,000, 3,000, 4,000 years, nobody has figured out how gravity works, what the mechanism is of gravity. And they give you some irrationality, such as, warp time, and what is that? What kind of, is that an explanation to say that time is bent? What is it? The seconds are bent, the minutes, the years. Okay, yeah, so all you have to do to explain, you got to put the rope in there, and then you can give an explanation. Doesn't mean people will believe it. It just means that what's going through your mind is this, that you're saying that the reason the donkey came closer to Casimir, your theory is that he was pulling, on a cord. Okay, so that's the theory. Okay, then you can talk about pull, because now you're giving a mechanism. Okay, so this takes us to this word object, okay? And this is what keeps everybody from understanding. People think that an object is that which you can see or touch, and see and touch are irrational criteria for the definition of object. You cannot use see or touch, and these are the reasons. You can't see air, okay, for example. Even though it's made of atoms, same as your chair, okay? You can't see the Klingons table on the other side of the universe. Then you see the picture on the right. You can't see that because he's a gazillion light years away from you. And does that mean that that's not a table, that's not a chair, that's not, there's nothing there? And you say, well, yeah, I have the potential, as some of these, idiots, whatever. That's what they say. They say, look, I have the potential, it has the potential to be touched. Yeah, but that means that until you touch it, it's not an object. A table is not an object. The word table doesn't refer to an object. When you see it in the dictionary, you see the word table, it's not an object. Of course it is. Table is an object everywhere in the universe, in every dictionary in the universe. It's a thing. Okay? So the question is, you can't say that because you can't see or touch it using that criteria, it's not an object. There are objects you cannot see or touch. And among them, we include the rope. Okay, so it's not a question of seeing and touching. And see and touch also require an experiment, and it involves two objects. You need two objects. You invoke two objects to define one, the word object. Great. And then the question is the asteroid not an object before it strikes the moon? Is the moon not an object because before the asteroid strikes it? And so, are we can see these two things out there. We see the asteroid coming towards the moon. We say, well, they're not objects until they touch each other. Okay? And yes, see and touch are subjective definitions because they depend on the observer. You need two objects. You need one of them to see and touch the other one. So you need an observer. And that's why it's a subjective definition. On the other hand, object, that which has shape, which is a scientific definition of the word object. My greatest contribution to science, by the way, not so much because I defined it, but because I found out how important the word object is to science and to physics. You can't do physics without an object. That's how simple it is. And it's subjective. Why? Because all objects have shape. If you can think of an object that doesn't have shape, please let me know in the comments section. Okay. So here we move on and we find out why haven't they figured any of this out? Well, because they never defined the word physics. They don't know what physics is. They have only irrational definitions for physics, mathematical physics, and what's the other one there? Theoretical physics. So we have theoretical physics, mathematical physics, and physics, and they all mean the same thing. Here's the first one. Here's physics says the natural science of matter, involving the study of matter. No study. We don't study in science. Okay, anybody can study. Even babies study in kindergarten. Does that make them scientists because they study? So studying is the wrong criteria, the wrong word to use to define any discipline out there, okay? Especially physics and science, okay? And it's motion and behavior through space and time. Through time? We're traveling through time. How do you travel through time? Is time a container and you travel through it? Is it a tunnel? What is time? How do you travel through time? What does that mean? And the related entities of energy and force. Energy and force belong to the religion of math. It has nothing at all to do with physics. We do not use concepts. We don't transfer energy. We don't push the force or pull it. And we don't use field. We don't vibrate the field because these are all concepts. Okay, so none of that belongs to physics. We don't use foul words, four-letter words such as energy and field and mass, not in science. Okay, physicist, a scientist who specializes in the field of physics, which encompasses the interactions of matter and energy at all length and time scales in the physical universe. What's a scientist? A person who researches. That's in Wikipedia. What's a physicist? A person who does research. Collins Dictionary. No, we don't study, we don't research. We don't do any of that stuff. Not in physics, not in science, okay? Anybody can do research, anybody can study and learn absolutely nothing. In fact, not even write a paper. So the guy studies, the guy did research, and we leave it there. Oh, I did research, I'm a scientist. No. Study, research, bad words, rational terms for definition of disciplines. In paleontology, we don't study. In biology, we don't do research. What we do is we explain. When you come to the conference, people don't ask, did you do research? Did you study? Yeah, I studied for the test. I got a 0. Great, you're a scientist because you studied. No, you got to explain. If you don't explain, it means you haven't used the gray matter in your head. Okay, what does theoretical physics say? It says a branch of physics. The tree, it's got a tree branch that employs mathematical models. Absolutely not. Well, maybe theoretical physics, whatever that is. In science, we only have physics, no theoretical physics. And abstractions of physical objects and systems to rationalize, explain, and predict natural phenomena. Explain, math has no power to explain. And predict, that's astrology, palm reading, one of those. And there you have it. Mathematicians are like Mary Poppins. You have Mr. Banks. He was the banker, okay, where she worked, taking care of his 2 kids. And Mr. Banks stops her because she did some boo-boo with 2 kids. And said, will you be good enough to explain all this? Mary Poppins says, first of all, I would like to make one thing perfectly clear. Yes, I never explain anything. And that explains or describes mathematical physics and theoretical physics. They never explain anything, just like Mary Poppins, no different. Okay, and now we have the last one, which is mathematical physics, whatever that is. Mathematical physics refers to the development, blah, 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 for such applications and for the formulation of physical theories. What's a theory? An explanation. Math does not explain, we're done. Okay, we're done. Period. Punto. No theories, explanations in math. Yeah, we have no theories or explanations in math. Physical refers to objects. So if you don't have an object, you're not doing anything physical, and math never uses objects. Math replaces objects with concepts. Point mass. They take the whole elephant, they weigh them and say it's got a mass of, 5 tons. And so they take the 5 tons, put it in a little dot and say the elephant moved. No, you move the dot, not the elephant. You want to move the elephant, you got to put the elephant back and replace the dot with the elephant. Then you can move the elephant. You can't say because you moved the dot that 5 tons moved, which is what they say. Okay, so math cares not Yoda about structure. Okay, so here we have it. My definition. This is the one we propose for science. Science, what is the definition? Rational explanations. Very simple. Okay, and rational, there's several criteria for the word rational. We usually define the word irrational, so that's easier to understand. You move concepts, you don't define your terms, or you define terms inconsistently, meaning, you clean your nose holes with your definition. The theory doesn't follow from the hypothesis, from the assumptions, okay, etc. There's a couple more. And so that's what irrational is. And explanation, we just went over that. It's essentially the interpretations. You're going to explain something, and that's called also a theory, okay? Especially, gravitational and electromagnetic phenomena. That's what we're interested in. Why? Because those are invisible and intangible. See, we figured out all the tangible stuff. It's the invisible, intangible stuff that we cannot answer. The mathematicians cannot answer. Why? Because they never proposed objects as mediators. And they say, I can't see or touch it. And so that's when you have to get the definition of object straight. That's why the definition of object is so critical, especially in physics. You can't do physics without the definition of the word object. Okay, so closing up here, math is a language, okay? It's exclusively a quantitative language. Math can only describe. Math has no power to do qualitative stuff. Okay? Yeah, it's a question of math cannot do lit. It can only do tit. Okay? Hope you got that. Math cannot be used to provide physical interpretations. One branch of math deals with measurement, which is only description, right? Distance, for example, meters, time, seconds, weight, kilogram, speed, miles per hour, etc. Okay, so that's what we have. Those are just descriptions. That's all that math can do. Physics, on the other hand, is exclusively qualitative. Definition is rational explanations of causes and mechanisms. Okay, we got all that? Okay, so here we have another fellow who asks a question or makes a comment. He says, if a tree falls in the forest and there is no one around to hear its sound, will it make a sound? The answer is no. Oh, okay, why? Because the most accurate definition of sound, accurate. Why do they talk about accuracy? What's accuracy have to do with anything? It's either rational or irrational. And this one's irrational, what he's going to say here, so we don't have to worry too much about it. But let's have a laugh here. Definition of sound is not that sound is waves in the air, but rather is the relationship between the vibration of the air and the eardrum. Rarefaction and compression, right? If there is no eardrum, there will be no sound. Okay, good luck convincing a deaf person who does not have an eardrum that sound vibrates while it doesn't even have access to test. Well, he doesn't even have access to test the sound. My God, poor fellow. I guess he studied at the monastery as well. Okay, so here it is. What we do in science, we kill the observer. There are no observers in science or in physics. We have to kill the observers. No witnesses are allowed. And this fellow thinks everything's about what the person heard. And so here we have a deaf person next to you, and you can hear the sound. The other guy cannot hear the sound. So his answer is, well, there is no sound because the deaf person cannot hear it. And so, yeah, he doesn't have the slightest clue about anything. Where this guy studied, maybe at a monastery, who knows. Anyways, let's set him straight. Sound is what the forest makes, okay? The tree falls, makes noise. That noise is called sound. Vibration already of the air that surrounds us, right? Now, what you're that's subjective. That's a objective definition of sound. Sound is what something makes, the vibrations in the air, right? Now, whether you can hear it or not, that's a question of, otherwise, there would be no sound in the universe because, we can't hear all the sounds that are in China, and they can't hear all the sounds we have over here. And so I guess there's no sound in the universe because nobody can hear what the other guy has because he's too far away. Is that your logic? So no, sound is what the tree made when it fell. Whether you can hear it or not, whether your friend can hear it or not is irrelevant. Whether the deaf person can hear it or not is irrelevant. Okay, that's an observer-related notion, definition. And of course, it's irrational because you're putting an observer. There are no observers in science, especially for no definition. We do not use observers in any definition. As soon as you do, it becomes subjective. And it means it's your opinion against mine. That's why we never put observers or witnesses or whatever you want to call them in science. Okay? Okay, give me a second here. Okay, so we have another fellow, and he says the following. He says, I think it's the same fellow, but I'm not sure now. The definition of the existence of a thing is a relationship between the existing thing and the observer. Again, we introduce the observer, right? These people want to introduce subjectivity in everything. They say, look, it depends on what the observer measured, what he heard, what he saw. They introduce the observer because they think in subjective terms. They're doing more psychology and psychiatry than they are doing physics. The universe is merely a product of the mind. Oh, is it? So when I die, the universe dies because it's the product of my mind, right? There's no universe for you. Everybody has his own universe, right, in his mind. Is that what it is? Merely a product of the mind because there is no universe without someone saying that the universe exists. Well, the universe cannot exist because the word universe is a concept, and concepts cannot exist in science, specifically in physics. Okay, it has to be an object. The universe is not an object. The universe is a concept. That means atoms or matter, if you want to say it, matter and space. That's the universe. Two things, even though space is not a thing, but it's treated as a thing in the definition of the word universe. Suppose that there is something in the universe that is impossible for any observer to observe. Yeah, exactly. What if you don't observe it? And so he said, no one can even observe its effect or monitor any information, blah, blah, blah. It is isolated from the rest of existence. Okay, great. But it still exists. Okay, depending on what you mean by exist. Have you defined the word exist? Of course not, because nobody has in the last 10,000 years. I had to be the first person to define the word exist because nobody thought that it was so important. Among them, atheists, theists, and agnostics who go around in circles talking about whether God exists or whether God doesn't exist, and they never define the word exist. Nobody has any idea what the word exist means. You look at the dictionary, all you find is synonyms, being and reality and just synonyms. We don't have any idea what the word exist is until now. Now we know what the word exist means. We have a rational definition. Exist has to be an object that has location. Okay, if it has a location, it's got an object that has location, it exists by definition, not because I say so. Okay, you don't have to agree to the definition again. You have a better mousetrap. Show us or keep your trap shut. And it says, okay, for us, there is no difference between the existence and the non-existence of this thing. Well, again, you have to define exist. Is it an object? Yes. Then it's got a chance of existing. Does it have location? Yes. Now it exists. If it has no location, it doesn't exist. If it's not even an object, it certainly doesn't exist. See how simple it was? Very simple. No observers necessary. No provision for observers in the definition of exist. For us, there is no difference, right? In this case, existence and non-existence have the same definition. Yeah, that's his conclusion because he never defined the word exist. Okay, so what do we say to him? Well, again, here it is. Okay. The mafia principle. We kill the observer. No observers in science, first of all, and no observers in the definition of exist. Okay, so keep that in mind. Exist simply means an object that has location. If it meets those two criteria, like if God is an object and has location with respect to all atoms in the universe, then God exists by definition. Okay? So if that's your proposal, if that's your assumption that God is a physical object and has location, hey, you've already made God exist for the atheist, for the theist, and for the agnostic, for all of them. All these religious people. Okay, here's a fellow who says the following: there needs to be a mediator for gravity, otherwise it's nothing but magic, like quantum entanglement. Yeah, so what do you propose? I mean, draw it. I need to see an image of it. I need to see what object you propose. And the question is whether that object pulls or pushes, because those are the only two possibilities, right, for gravity. Either you push maybe with particles, right, or you pull with some elongated object, I would think, right? But maybe you have a different version, different theory, no problem. Put it forth. Draw your thingy, whatever it is, the mediator, and tell us whether it pushes or pulls. Very simple stuff. Okay, and another fellow finally says the following. Says, if you release a pencil, it falls to the ground. But if you release a balloon with helium, it rises to the higher part of the atmosphere. He was talking about gravity, right? And yeah, then the question here is, it's no different than stating why you don't fall through the floor. I mean, why don't you go through the floor? Why do you float in water? Or why does a balloon float in, or your rubber ducky? Why do they float in water? And why don't they go through the floor? And, you can say it's density. You can say that the atoms also, say the ground or the table or whatever, are rigid, and that's why things don't go through them easily, right? And maybe a bomb does. Huh? Density is the antidote to gravity. Okay, you have all these people called flat earthers, another idiots or idiots or whatever you want to call them. Okay, and they believe that density is what causes gravity. Okay, great, whatever density is. Okay, so if the moon were covered in water, you wouldn't be able to fall at 1/6 the gravity on Earth as it is now. Can a pebble fall through the ground floor? Why not? Tell me why not. Okay, is that density or what is it? Can a drop of water sink in the center of the Earth, to the center of the Earth? You have the ocean. Why don't those drops fall all the way to the center of the Earth? Okay, so you got to tell me that. Density, is it the ground is too hard for them? What's the reason here? Are they all pulled by gravity towards the center of the Earth? And there you have the two scenarios. Okay, the one on the right is the normal one where you have air and you let go of a piece of metal and a feather there, and it falls very slowly because you have air. It's going through the air, and air offers some resistance to the feather. Well, it doesn't for the piece of metal there. And on the left, you see there they took all the air out, and you can see they all fall straight down, like if gravity pulls on both of them. No density there. Okay, so you got to explain that. And here's another version of that. Let me show it to you. Brian Cox, he went to this place, and here it is. Let's see if from the beginning they dropped this. And this is under vacuum. It took the air out, or most of it, and you can see that the feather and the ball fall at the same time. Whereas when it's not under vacuum, here you'll see when it's not under vacuum, you'll see what happens. Normal stuff, the ball falls immediately, and the feather takes a long time to come down. Okay, and here you'll see one more time that do falling at the same time because they're under vacuum. Okay, so yeah, you got to answer gravity, and hopefully it's not this nonsense that the flat earthers call density, whatever that is. Okay, again, density is a concept, and they don't understand that. We need a physical object. We want you to tell me what comes in contact with a feather or the ball or whatever, or the metal piece there. Why don't they go upwards? That's what I want to know. Why is it the density on the upper side? We have air covering the earth, right? That's why we can breathe. So why doesn't the feather go upwards? All the way out of the earth, all the way out of the solar system. That's what we want to know. Please tell us. That's where you would use your brain a little bit. So far you haven't. Okay, and fellow says, will you ever use your theory to do any real world predictions, applications? Aha. Wouldn't it be cool project to use your rope model to build a working GPS receiver? Well, what's the answer to this gentleman? The answer is, we do science here. We don't do technology. Okay, and what he's asking is there any practical use for the theory involving the rope, which we call thread theory, by the way? And the answer is no. Science has no practical use whatsoever. People confuse physics with technology, or science with technology. And what do I mean by that? Well, you have people who say that GPS proves general relativity correct, and that computers prove quantum correct, that they're true theories. What do you mean by that? What do you mean the computer proves that quantum is correct? Does a computer, the fact that we have computers, this technology, does it prove that a particle can be at two places at once? Is that what it proves? Does GPS prove that time is a physical object and that you can bend it, which is what the conclusion of these people is? So the question is, does technology prove a theory? And the answer is absolutely not. Technology has absolutely nothing to do with physics, okay, with science. And we have to separate those two things. People have this in their minds. Oh, look, all the technology we have today. We wouldn't have it if all the mathematicians were wrong. Mathematicians have nothing to do with the technology we have today. All technology is developed by trial and error. Or like Thomas Edison said, I haven't, I haven't failed, he said. I just discovered 10,000 ways that don't work. He kept trying one thing after another. Did he know what electricity was? Did he have to know electricity? Did he need to know any math? No. All he needed to do was try one thing after another until he got it right. He said he tried one filament, he tried another one, finally got it right and said, this is the filament. And he made it cheap and available to everybody. And then they came with other filaments later on, tungsten and so on. This is trial and error. It has nothing to do with physics, with explanation. So yeah, the rope model, if it helps you in any way, think in a different direction for developing some technology, well, more power to you. That's not the intention, okay? Physics and science have nothing at all what to do with technology, okay? So these are two different, you could say, disciplines. You can take that to the bank. Okay, let's get on with time travel. What in the world is time travel? Well, again, we have to begin with our definition. Let's define this one more time. We defined it several times in several videos, but let's do it one more time. What the hell? There it is, idiot or idiot. You can pronounce it any way you want. Okay? Individual with big ideas. That's what an idiot is. And it comes from the old Klingon, meaning big idea. We have little ideas, normal ideas, and then we have big ideas. Okay? And yeah, and so who are the people who have big ideas? Well, most of them are called special relativists. Okay? And they have these weird big ideas where they say that time can be bent. Time can be bent, can be warped, And they say that length can be stretched simply because a particle travels very fast. It stretches. It shrinks. Its length contraction. They shrink. They shrink the ruler or whatever you're carrying, right? And the mass increases. It gets heavier and heavier and heavier. And what is mass? Mass is the quantity of matter. And so are we padding it with more matter? Is that what we're doing? That's why it's becoming fatter. Well, I don't know. How can it shrink, length contraction at the same time, become bigger, like, more mass? So, you figure it out. But that's why we call them idiots or idiots, right? Because they have big ideas. Okay, so we have to settle that because we're going to have a lot of big ideas right now, so be prepared. Okay, one of the things they talk about, one of the biggest ideas they have is time travel. They say that you can travel to the past or to the future. To the future is guaranteed. They already know that. It's proven. There's no discussion. To the past, there is still some debate. A lot of people say, well, I don't know if that's true. Others say, yeah, mathematics prove it. Maybe it's within the laws of probability. Science allows for it, physics allows for it, the equations allow for it. Okay, so they have all this stuff. So what are they talking about? Well, they're talking about this. They're saying, here you are in the modern world over there on the right, computers and so on. You walk through the time tunnel or rush through it at the speed of light or whatever, right? And you end up, I don't know, in the 16th century. You started out with a watch, maybe a wristwatch or a timer of some kind. And you end up with a sand clock, an hourglass. Okay, so yeah, this is the notion that they have. They call it science. You say, Bill, well, that's not science. That's not part of physics. It's philosophy of physics, philosophy of science. Maybe what was it? Natural philosophy. Someone said. No, here it is. Look, I'll prove it to you. Proof, evidence. Okay, here we have it. And here it is. This is, you just put time travel on Google. You just Google it. I got 7 million results for scientific papers. That's what I put in there. Okay. Now I didn't take the trouble to look at the 7 million. Believe me. I just took a first page there, a few of them, and you can see that it's quite a popular subject. Okay. In the archive there where people put their papers before they publish them, right? And you can see the dates there on some of them. And even to this day, people talk about this nonsense called time travel. So yeah, what we're talking about here is that people actually write about this in the what they call the scientific literature. Okay, so and the question is, who writes about this stuff? Does it involve philosophers of physics or natural philosophers or philosophers of science? No, it's mathematical physicists who write about this and try to publish their papers. It's theoretical physicists. It's what they call physicists who do all this kind of work. So here when you put them against the wall and you call their bluff, they say, well, that's philosophy of physics. Well, if it's philosophy of physics and that's not part of your job description, it's not part of your line of work, why in the world are you giving me a physical interpretation when you have no authority, no expertise to do so? Okay? So it's only when you call their bluff, when intelligent people confront them and say, you're talking nonsense, and they say, well, that's philosophy anyway. That's when they dismiss it. And who are the people who are writing all this nonsense? The so-called physicists, theoretical physicists, mathematical physicists. And so here we have a summary from SIAM, okay, Scientific American. Is time travel possible? Okay, and this came out in 2023, so you can see it's a very contemporary subject. Okay, scientists don't relegate time travel to the crackpot realm. Okay, they only relegate to the crackpot realm. The rope model, maybe some others, right? That goes into the crackpot realm because they decide what's crackpot. But this is not crackpot. In fact, the laws of physics might allow chronological hopping. Laws of physics What laws? Who dictates these laws? Is it the people in Cambridge, or is it the pastors at Harvard? Science began to take time travel seriously in the 1980s. Time traveling to the near future is easy. If a person were to hang out near the edge of a black hole, only a few hours might pass for them, while 1,000 years went by for someone on Earth. If that person who was near the black hole returned to this planet, they would have effectively traveled to the future. That is a real effect. That is completely uncontroversial. It's a done deal. They proved it. You can't challenge it anymore. Going backward in time gets thorny. Scientists have come up with a few ways it might be possible. So they haven't, they still haven't let go of this. Okay, it's still there. It might be possible. A closed time-like curve describes the trajectory of a hypothetical observer that, while always traveling forward in time, whatever that means, how do you travel forward in time? Is it a tunnel? What are you doing there? From their own perspective, at some point find themselves at the same place and time where they started, creating a loop. Well, it depends on how many beers he drank. I mean, maybe he thinks at the same place where he started. I mean, how can he end up in the same place if he went forward in time or backward in time or whatever, right? And so this is possible in a region of space-time that, warped by gravity, loops into itself. Absolute poppycock, all this. Why does time travel depend on exotic matter? It is needed to hold open a wormhole, a tunnel in space-time predicted by general relativity, that connects one point in the cosmos to another. So you can see time travel is still alive and well, and we're going to make sure that it dies a sudden death today, okay? Let's make sure of that. And yeah, here you see Brian Greene. He's going into that time tunnel. Okay, he's going into the past. And here it is. He comes up to where he was early in the morning, shakes hands with himself. He jumps into the time tunnel or wormhole, whatever that is. Doesn't look like zero-dimensional or one-dimensional. It looks like three-dimensional to me. And I don't know what it's doing there in the middle of the airport. But yeah, he does this, jumps in there, and he ends up with himself in the morning. Okay, shakes hands with himself. Now, is this science or what? Okay, and we're going to debunk this nonsense today. And again, we're not going to debunk. Doesn't mean we're going to convince you. We're not interested in convincing you, or persuading you, or recruiting you. We're going to show the irrationality of what they're talking about. Okay, that's what we're going to show. Okay, so debunking here means we objectively show that it's irrational. What's irrational? Well, when you move a concept, when you have definitions that are inconsistent or you use them inconsistently, right? And theory doesn't follow, the explanation doesn't follow from the assumptions. Okay, and here we have another fellow, and his name is Neil deGrasse Tyson. What does good old Tyson have to say about time travel? You're going to have to read here, okay? So here goes. I made it go as slow as possible so it allows you to read, so pay attention. Here goes. Okay? So the only reason they rejected time travel to the past, they accepted the future, but the reason they have a problem with that in the past is that you can kill your grandfather, your father and mother or whatever, and then you won't be born. And so they say, well, that sounds like a little contradiction. Of course it's a contradiction, idiocy. So why are they even considering this nonsense in published papers by physicists? Okay, that's what that's got to be worrisome. Here you're paying all these people indirectly, sometimes through government taxes, etc. Go to these people, and you're paying for all that indirectly anyways. And these people are looking at time travel, and they call it science, or they publish it as scientific papers. And then when you call their bluff, they say, well, it's only philosophy. And it turns out no philosopher is writing papers on that. It's all so-called physicists, mathematical physicists, theoretical physicists. So that's what you got to look at. There, we have a contradiction there. Okay, and so how do we start this thing? Well, the criticism of this thing, okay, time travel. Well, we're going to present this. This is our universal movie. It's a tool that we use to challenge ridiculous theories from idiots, idiots or whatever. And what we're showing there is that in a single frame of the universal movie, it's a 3D movie. It's the one God runs, I guess. We have only this movie that's moving from one location to the next. Every atom in the universe is there in a single frame, and every atom in the universe only has distance with respect to each other, and it's moving to a different location. It's moving from location to location, but a different location means you're in a different frame of the movie. Okay, so that's the notion we have here. In a single frame, all you have is static concepts, okay, such as object, distance, location, and existence. These are examples, right? And there are others like standing, sitting. Those are also static concepts. They're not dynamic, okay? On the other hand, on the bottom there, you have, you require at least 2 frames for any of those. You need 2 frames to talk about motion, position, plasma, ether, field, energy, time, and so many others. Okay, so we're looking at a single frame. A single frame only has static concepts such as, especially location. That's one we want to focus on today. Location. Okay, so hopefully we got that. What we're showing with this universal movie, we're only talking about objects. They have specifically atoms, right? And every atom in the universe is in that frame, and they all have a certain distance with respect to each other, and we call that location. Okay, the set of distances from all atoms to one atom in the universe, the gazillions of atoms to one atom, we call that location. The location of that atom with respect to all the other matter in the universe. That's location in physics. Okay, location is not, so much on the x-axis, so much on the y-axis. We don't care about that nonsense. Location is physical. It's just the separation from one atom to all the other atoms in the universe. Some very close by, and the other ones very far away. Okay, that's our starting point. I hope you understand what the purpose of that the universal movie is about. Okay, so here we have the Christian version of creation, right? And so we have a single frame there, which is Adam and Eve on the earth. Okay, so God creates the earth, I guess, in, he was moving over the waters, started creating piece by piece. And the question is, for any of those films, we want to know how he went from frame 1 to frame 2, where he suddenly creates man, from nothing, or creates the first bit of matter from nothing. So how did he go from the frame on the left to the frame in the middle? That's what we want to understand. What is the mechanism? What is the cause? How did he do this in his garage, right? We want to know the mechanism. And of course, there's no intermediate frame because we're taking the next immediate frame in the universal movie. So there's no intermediate frame. That means there can't be a mechanism. We already have the contradiction in that image right there, because we go from nothing to something with no time. Okay, so that's the starting point for Christianity. Not very good. What God really does, it really creates the universe eventually, I guess. And here you have a dynamic version of that. And you say, Bill, why did you put it in a single frame? Well, we put it in a single frame because that's how the mathematicians see this. They say that all that time involves motion, and it's dynamic. But they say the universe, the entire shebang, the entire universe, the entire space-time, which is what you're staring at there, is in a single frame. The past and the present coexist together with the future. It's all in a single frame. In fact, let's stop that so that you can see what I'm referring to. That's what they propose. They propose that, that there's a single frame, and we have all the time in there. We have the past, present, and the future all in that block, which they call the block universe, space-time, whatever. And that's why they can get away with saying that if you're in the present, you can travel to the past because it coexists with the present. So you can go, each one of those slices there, by the way, that's time slices of every, what we call the single frame. But see, they put all those slices, which are different times, they put it all in a single frame of the movie because they talk about the block universe coexisting at the same time, past, present, and future. Okay, so let's get that straight, what they're proposing. Okay, so the only other thing that they do is they get rid of God. Poor old God, they get rid of him, and they have only, the block universe there, But the question we want to understand is the first two frame, not the frame gazillion there. We want the first frame and the second frame. They go back in time, what they say, and they say they go to frame number 2, and they start with a singularity. And so the question is, how did we go from nothing to the singularity? How did that singularity get there? Whatever that singularity is, we don't care. It's got to be an object because that object gave origin to all of matter. So we just want to know how we went from frame 1 to frame 2. That's what they need to explain. And of course, they say that frame 1 is unscientific, that it's irrational to ask that question because they cannot verify through an experiment or who knows what how that came to be. Yeah, of course not. That's the only thing that they have to explain. They have to explain how it was possible for the singularity to come into being. Okay? Until they can answer that, they have not understood absolutely anything, okay? Or they cannot explain anything. Okay, so what are they saying? And here's the key point, okay? Listen to this. Okay, here we have, under the universal movie, right? We have all the atoms in the universe. We're only going to look at 5 of them. And these 5 move with respect to all matter in the universe, okay? And so we only draw these 5 atoms, and you can see that they're moving across the screen, okay? And remember what we're going to do. We're going to go from 457. We're going to take one of those atoms, and we're going to take it to frame number 454, because that's what they say when they travel into the past. We can also do it in reverse. Take an atom from 454 and take it to 457. What's the problem with this? Well, let me show you what the problem is. The problem is that these people are not saying that anything moves in the universe. What they're saying is that every time that the atoms move to a new location, they in fact did not move to that new location. What they did was they created new atoms. They made copies of those atoms, okay? Because the only way you can move to find an atom in the past only if that atom is still there, okay? That means we're going to duplicate all these atoms, and here it is. This is what's happening according to them. They're creating copies of the atoms every time they move along, okay? So they're making new atoms, new matter in the universe as you move along time. There is no motion. There is only a creation of matter, okay? And here, let me show you a little picture, okay? Look at this carefully. I just want you to see what they're trying to do here, okay? Here goes. Okay, so this is what we see. We're saying that the guy on the left there can go visit the guy on the right only because we have all these frames still in existence. Otherwise, how can you go back and see the guy on the far right there? You can only see his hat there, cap. The only way you can see him if he still exists there. That's the only way you can shake hands with him. And that means all these frames exist simultaneously. That means we created new matter. This guy never moved. What he did was we created new matter. We created a new person for every one of these shots that depict him. Okay, so we're creating new matter according to the idiots of math. Okay, that's what they concluded. So there is no motion. Okay, what we have is creation of new matter every time you think you move. Okay, so let's start with this. We're going to show this. This is our universal movie. Okay, and just at random we pulled some frames out of there, right? And this is the universe, as you can see there. In each one of those frames, you have all the atoms in the universe. Okay, and okay, so what do we propose? Well, we propose that all that matter there is really a single thread, okay, that weaves all that matter, atoms and the ropes that interconnect them, okay? So this is what we're proposing. That's different from mathematical physics. Mathematical physics proposes discrete particles. That's what they've always done. We call it ether. That's what mathematical physics has always had. They just gave it different names, space-time, false vacuum. They're talking about the ether. They're talking about particles. Why? Because a particle is not a particle. A particle has become a number, a value. And what they do, they move these values, and they talk about the value that they move, and that's what they're going to put in an equation. They have no use for dots for particles. So the particle has stopped being a particle, a corpuscle, the classical one. And what we propose is that all atoms in the universe are physically interconnected, and there we try to show as best we can that the atoms are connected. Okay, so that's the difference with mathematical physics, the fundamental difference. Okay, and what comes out of this? Well, we have this. Give me a second here. We have this. The one on the right has become a single thread. We're saying that a single thread underlies all of matter, okay? And math phys remains the same. Nothing changed there, okay? And what does this thread do? Well, this thread weaves around and constructs what we call all the atoms and ropes that interconnect them. And here it is. This is how we visualize all this. We're saying that the thread turns into these two electric and magnetic thread that serve as connectors, physical connections between atoms. The atom is made of the same threads. Okay, that's why there's a single thread in the entire universe that weaves all atoms and ropes that interconnect them. Okay, and this is more or less what an atom looks like. According to us, that's a 2D version of it. Okay, and here we have our atom looks more or less like that, the 3D version on the right and the 2D version on the left. And what they're doing is quantum jumping by going back and forth. The electron shell or membrane, balloon, whatever you want to call it, expands and contracts at great velocity. What it does is, by doing so, it torques the rope, and that's why light travels always at the constant speed. It only exchanges frequency for wavelength and vice versa. Okay, and so there's your quantum jump. That's our atom. That's our model. Okay, so the point here is that we are proposing that there's a single thread in the entire universe that weaves all matter. So if we were to dismember every atom and every rope in the universe, we would end up with a single thread. And that's different than what mathematical physics has always proposed, and all dissidents, they all propose particles, discrete particles. They try to do it with discrete particles. Push, pull, the whole works. And that's why they cannot explain pull, because they've always done it with discrete particles, and you cannot pull with rocks. And that's why they never figure it out unless they change their assumptions. Okay, so this is the universe. Now we're going to untangle all matter. Okay, we're going to disassemble all the atoms in the universe, and we're going to have the thread there. Okay, that's what you see there. But according to the rope model, matter cannot be at two places at the same time, like in mathematical physics. And so what happens? All these frames that you see there are really in existence. This is the only one that's there. Here, let me show it to you. And it's the one we're going to call the present, frame number 457. Okay, all the others are imaginary. In other words, they're in our brains. They don't exist in reality. Okay, so there's only a single frame, and that contains all the matter in the universe, right? It's like God froze the entire universe, right? Every bit of matter, nothing moves. There's only a frozen universe, static, and we're going to disassemble that, and there you see it. That's all you would see. So let's erase all these other frames. That's all we have, really. That's reality, the present, okay? And I like to put it this way, Father Universe, he only exists in the present. He doesn't live across time or through time or whatever they call it. He doesn't have motion, okay? Father Universe does not understand motion. Father Universe only has location, okay? I hope you're understanding, okay? It doesn't mean you believe in it, doesn't mean you accept it. I just want you to concede it now so that you can understand the theory founded upon it. That's the way we do science, okay? So we're going to concede the assumption just for the sake of argument, and here it is. We're going to have you, and there's you with a little atom that's on your shoulder. We're going to look at that little atom, the red one there, in frame number 457, okay? But remember, we're going to erase all the films, all the other frames, okay? Because they don't exist, okay? So all frames before 457 are in your head. They no longer exist. They happen. They're no longer there. In other words, all those locations of atoms, that disappeared. We have a new location, which is at frame 457 of every atom in the universe. And one of them is the one that you have on your shoulder. So this is the correct way of depicting that all the others do not exist. The only one that exists is the one frame that we just froze, and we'll call that the present. So far, so good, okay? And here, we're going to look at, we're going to try to move that atom to the past. Okay, that's what we're going to try to do. So here it is. But we're going to move it to a frame that doesn't exist. Okay, because that frame 154, really doesn't exist. But that's what these people claim that they can do, that they can take an atom, that's part of your body when you travel. So we're just going to look at one atom, and we're going to say, hey, we're going to make that atom travel through time, and it's going to go to a frame that no longer exists. Okay, because there's only so much matter in the universe. We're not creating matter every second as mathematical physics claims it does, because it says it can travel to an existing you in the past, or an existing Napoleon, an existing Caesar, or whatever. Okay, so that means Caesar didn't die. He's just in a different cross-section of time. You can still find him there, shake hands with him. That means he's still there. Okay? So this is important to understand, what we're talking about here. Okay, so here we have, we're going to assume now that that frame exists. Okay, let's assume it exists, because that's the assumption they make, that in reality, the frame when you were in the past, anytime in the past, still is there, and you can go see yourself. Okay, that's what they're saying. Okay, so we're going to assume that it exists. So that means we're going to look at that same atom in your shoulder a few days ago. For example, that atom is still there in both frames. It didn't disappear. We replace our atoms in our body every so often. You probably have a dinosaur atom now, or an atom that belonged to a dinosaur somewhere in your body. You ate something that used to belong to a dinosaur. That could have happened. But in a few days, we're going to say that that atom was still in your shoulder. Okay, and so we're going to try to take the one in your shoulder at 457 and we're going to take it to frame 154. Before we do, we got to show you this, because we're going to replace you really with every atom in the universe, meaning the thread that winds every atom in the universe. This is what we really have. And there's your atom. Okay, it's part of the thread of the universe. Okay, the single thread, as we call it, the closed loop thread that makes up all matter in the universe. Okay, I hope you follow through. And what are you trying to do? Well, this is what you're trying to do. You're trying to not only send it to an inexistent frame, but you're dragging the entire thread from our universe to that other frame where you have that other universe over there, which is the same universe as ours. So you're distorting completely our thread when you do something like that. You're pulling on every atom in the universe when you go through time to a different frame. Okay, to an inexistent frame, really? Okay, so this is what these people are saying that you can do. And of course, under the thread model, the rope model, you can't do that. It's totally irrational what these people are proposing. And again, let's understand what we're saying here. We're saying that in order for you to visit yourself yesterday, that means that for every second, for every microsecond, gazillions of a second, every frame in the film, we made a new you. Every atom in your body, instead of moving to that frame, what they did, they created a new you, and the original you was still there. And they created all these yous. You have all these yous. That's the only way that you can explain what they're trying to do, which is to visit yourself and shake hands with yourself in the past. Or in the future, because this applies to the future as well. It's just as much nonsense to say you can go to the future as you can go to the past. And even they say, well, it's only for a little while, even for a little while. You can't there's no such frame there for you to land on. There better not be, otherwise you've drank too much beer. You got to take it easy with the beer. Okay, what are our conclusions? Well, here are the conclusions. Father Universe only exists in the present. He's always in the present. What is the present? Location, distance, from atom to atom in the universe. There's separation between every atom in the universe. And the only thing that we want to add to this is that we say that there's a single thread that weaves all these atoms in the universe, but it still doesn't take away from the fact that Father Universe only exists in the present. Father Universe does not live, he's not alive, and he doesn't move through time, or he doesn't move at all. Father Universe always wakes up, looks at himself, says, okay, every atom is where it should be right now. They all have distance with respect to each other. Every atom has location. Each one is an object, all in a static, single frame of the universal movie. Then he goes back to sleep for an eternity again, right? And then he wakes up and again says, okay, every atom has location. I'm okay then. And so he always lives in the present, or exists in the present. As long as you keep the wording correctly, then you're going to make sense. But as long as you don't define your terms like they do in mathematics, you'll never understand anything. With that, I'll see you next week. Bye-bye.